Hello everyone, welcome to the another very important session in which we will be discussing some more important questions and the concepts for our upcoming CSIR net and the GATE physics exam. So I hope that the discussion which we have done till now in our previous classes, all that will be clear to everyone. But in case if anybody is having any doubt anywhere, we can surely talk about it. So initially, I'm just quickly going to show you some of the steps which will be helping you to take your Unacademy subscription related like it will help you to start your 7-day free trial. As you can see, it's mentioned here. So what are the steps you have to follow for that? That's all I'm gonna show you right now. The step number 1 is shown on the screen. You have to enter your phone number. Step number 2 will be you have to verify your OTP. Then next is you have to choose your target like the CSIR UGC net. Next is you have to enter the activation code. Then next is you have to download the app to start your preparation. That's it. These are the steps you can take to get your free trial, okay, on Unacademy. I hope these steps will be helping you guys. Now next we are going to talk about the other important steps you have to take, okay, or other important things related to Unacademy learning app. So this is regarding the Unacademy learning app, guys. This is something related to the session. This is something related to me, and here we are having the information about the community feature we are having on Unacademy learning app, and that will help you to stay updated to know about the important things, new sessions and new updates. Now guys, next thing we are gonna have is the information about the Unacademy Plus Iconic and the Lite subscription. Even now the important notes are available on the learning app, which will be helping you a lot to take your preparation to the next level. And guys, you can use and apply the code Anjali A Live to get the discount in the total subscription amount. Okay, now let's go ahead and let's start the discussion about the important questions and the concepts we will be considering in the session today. So this is going to be the discussion related to electronics we will do today. And if in case anywhere you will be having any doubt, you can surely let me know about it, and we will try to consider those points then. So I'm going to start giving you some questions based on electronics. I will try to take the questions from different topics, concepts and the points. So if anywhere you will be having any doubt, you can surely let me know about it. But if everything will be getting clear, then that's great. So let's take our first question right now. A time varying signal. V in is fed to an op-amp. Circuit with output. With output signal V naught as shown in the figure below. The circuit implements I'll be drawing the circuit on the next slide. High pass filter with cutoff frequency. Hertz. Option B is high pass filter with cutoff frequency 100 hertz, low pass filter with cut off frequency 16 hertz. Option D is low pass filter with cutoff frequency 100 hertz. And the options are, oh, these were the options, and the figure is negative, positive. Both the terminals. Here we have the resistance. This is for 1K and this is grounded. This one here you have is again 1K, that's 1 kilo ohm. And then you have a feedback resistance which is of 10 kilo ohms. And then further you are gonna have this terminal here which is V0. That's it. This is how you're gonna have all these important parts mentioned. The next one is this. Here is a capacitor. Here is again a resistance. The capacitor is 1 microfarad capacitance. And then this is 10K. This is again 10K. This is going to have another op-amp present here. Oops. Okay. This is grounded. Okay guys, this is what we are gonna have like in the circuit, and now you just have to consider what seems to be the correct option. You just have to analyze every component. Let me just show you the positive and negative terminals of the lower op-amp, and that's it. Now just consider all the parts and tell me what do you think is the right answer here. If in case you will still have any doubt, you can tell me. I'm just going to wait for everyone's reply and then we will be continuing the discussion. Waiting for your reply, guys. Nobody has replied till now. Otherwise, I'm going to start the discussion too. So first of all, you have to consider that what kind of circuit it is, okay? And then you are gonna go ahead to consider it further. So if you're gonna see the arrangement of resistance and the capacitor, so you can see the resistance is present on the input path and the capacitor on the other side. That's like one of the ways you can consider to find whether it's a low pass filter or a high pass filter. And in this case, the circuit which is shown to you is representing a low pass filter. The capacitor is on the feedback path as well as your resistance is on the input path, right? RC combination or CR combination, these are the two things which can help you to understand whether it is going to be a low pass filter or a high pass filter. The other thing anybody can do if they are confused about the presence of the capacitor and the resistance and you are not able to identify it, then you can consider the concept of gain. So when you will consider the voltage gain, that is V output over V input, and you will find its expression, the ratio. You just have to get the ratio of output voltage to the input voltage, and then let's say here you will have V input. So in that case, you are going to consider that at the higher frequency, and from where you will get the frequency from the capacitor part, right? So if at the higher frequency the gain will be high, which means it's a high pass filter. At the lower frequency, if the gain will be high, means it's a low pass filter. So depending on what kind of expression you will get, you can decide whether it is a low pass filter or it is a high pass filter. And once you get that, to get the cutoff frequency, you are just simply going to use the formula, which is Q pi RC. Okay, so 1 over 2 pi RC, this is going to give you the final answer. Tell me if in case there is anybody having any doubt, we will be trying to consider it then, but if it is clear, that's great. So you can let me know if you have any question, query or doubt regarding this. 1 over 2 pi RC, guys, the resistance here you are going to plug in, okay? And you can see the RC combination, the C is present with 10K, right? So you're just going to consider that as the resistance, and then other one is going to be 1 microfarad. So when you will plug in all these values, after simplifying, you will be able to consider your cutoff frequency as 16 hertz. So low pass filter with the 16 hertz cutoff frequency, which is going to be our option C. That's the correct answer, okay? If still anybody is having any doubt, just let me know. Otherwise, I'm going to give you the next question. So cutoff frequency 1 over 2 pi RC. To find whether it's a low pass filter or a high pass filter, what you will do, you can find the gain if you are not so sure about the combination. While RC combination is showing you low pass, the opposite will CR will show you high pass. But if I'm going to talk about the next thing, that's going to be let's take this question now. This is also from OPEM, but not exactly same. It's quite different. The circuit is V input. Let me just write there. That's it. Okay, guys, try working on it now and let me know whatever you think is the correct answer. If in case you will have doubt or difficulty in considering it, I'll explain it then. But start working on it and tell me if you think you got the right answer, and still if there will be any doubt, I'm here to help you then. So these are the options shown on this slide and the question statement, while you have the figure or the circuit given here. Okay, guys, let me just quickly explain this to you. I can't see anybody's reply or the right answer in the comments from anyone. So I'm going to talk about it. The first thing we will do is we will try to consider the gain of this expression. But whenever you consider the gain, you have to identify the circuit. In most of the op-amp circuits, either the input will be provided on the negative input terminal or the positive input terminal or both of them. Otherwise, at a time, one will be grounded and the input is provided in one of the input terminals. Okay. So in that situation, what will happen? In that case, you are going to find the gain. Gain is V output over V input, which is going to be equal to minus RF over R in, since it's the inverting amplifier and the input has been provided on the negative input terminal. So you are going to get this as the gain expression. And you can even prepare the gain expression for inverting, non-inverting, and different cases. Now, what will be the feedback resistance? Since you can see one capacitor and another one as a resistance are present in parallel. So what I'll say, okay, the resistance multiplied with 1 over j omega c divided by resistance added with 1 over j omega c. That's your feedback resistance. Because of the capacitor present there, you are taking its impedance to be 1 over j omega c. So this is going to be your equivalent resistance or the feedback resistance now. Once you got it, what you have to do next? That's going to be V output over V input is equal to minus RF equivalent, which is the one expression I have noted down there, divided by R input. R input is 1K. So whatever you will get from this expression, you will plug it in here, and R input is 1K, just enter it here. And then you need to find the output voltage. So V input is already given to you, which is 5 sine 1000 T. You will plug in that value here, cross multiply it, you are getting V output. So you can see in the options, they didn't take the sine 1000 T. Means they are taking its maximum value to be 1, and then they are just writing the expression there. Okay, one more thing I know about the final answer you will have is 5 over root 2. But you can see none of the options, they have taken the square root in the denominator. which means you can multiply and divide by root 2, and that will give you option C to be correct, which is 5 root 2 over 2. That's it. This is how you are going to get your final answer. You can still tell me if you have any doubt or any step is not clear to you, anywhere you are not finding it, like not able to reach to the final answer, or any doubt you have, just tell me. We will talk about it. But if everything is clear, then that's great. We will go over the next question. I'm still gonna wait for your reply, or even if somebody is completing it, they can do it. And if you will stuck somewhere or you will find something is still not clear, tell me, I'll talk about it. Okay, or otherwise, just in some time, I'm gonna take the next question. Waiting for your reply, guys. If you have any doubt, tell me. Okay, I think it's clear to everyone, so we are ready to start the next question. That's quite interesting. If one of the inputs of a JK flip-flop is high and the other is low, then the outputs Q and Q bar oscillates between low and high in race around condition toggle, and the circuit acts like a T flip-flop. Option C is are opposite to the inputs. Option D is follow the inputs and the circuit acts like an RS flip-flop. Try it now and just see what you can consider from the given options, what information you are going to get. Is it helping you to know about how the changes needs to be made in the JK flip-flop circuit to like see if one of the inputs of a JK flip-flop is high, okay, one of the inputs you have to keep high and the other one you will keep low, then the outputs are like which are Q and Q bar, will they oscillate between low and high in race around condition? Will they toggle and the circuit will act as a T flip-flop? The uh, outputs, they are going to be opposite to the inputs. They will follow the inputs and the circuit acts like the RS flip-flop. So you just have to compare, you just have to see how your circuit will behave and what it will tell you, what outputs it will give you. That's what you have to consider. So tell me guys, if you're gonna have any doubt, I can talk about it. But if you can consider, see, let me just tell you. In JK flip-flop and in the RS flip-flop. So what happens in the RS flip-flop, if you don't have the same inputs like 0 0 and the 1 1 when the clock pulse is high, right? So in that situation, you are gonna get like one of the inputs exactly same at the output Q. And the same thing happens with the JK flip-flop for the not equal inputs for the J and K, like in that case R and S. So it will be behaving as the RS flip-flop and the inputs will be followed to the output side. So if you will have the clear idea about the circuit and you have prepared the flip-flops, you can easily relate this part. So it's just more about the circuit thing. But for the, since if you will see the RS flip-flop, it gives you forbidden condition. Just to remove that condition, we are going to make the changes. One of the outputs of the RS flip-flop, we just take it back to the other side input, okay, and the other one we take it back to the other side output. So sorry, input again. So that's the only change in the RS and the JK flip-flop circuit diagram. But in the truth table or the table which tells you about the output, the unequal values of RS and JK, those conditions give you the same kind of outputs which are followed as the inputs have been taken to the output. So that is going to be similar to RS. Hence your option D must be correct in this case. So this is how it's going to work, and that's giving you the option D to be the correct one. Okay. You can still tell me if you're going to have any doubt. I can talk about it. But if it is clear, that's great. I'll be taking the next question now. If still anybody is not gonna get anything or having any doubt, mention it, mention it, mention it. the circuit. I in the circuit is, the current I in the circuit is, it's not circuit, it's current. Options are option C is 6.7 milliampere. Try it now and let me know as you will get it done. If in case still anybody will have any doubt, guys, we can talk about it then. But if everything will be getting clear and you think you can solve it, just try it. If still you will have doubt, I'll be helping you in that case. But I want you to try solving it. So the IV characteristic of the diode in the circuit below, okay, is given by, that's the I expression. Like for different voltage range, what will be the current expression that has been shown there, where V is measured in volts and I is measured in amperes. The current I in the circuit is, so you can see the battery is like given as like the 10 volts and then 1 kilo ohm resistance, current, and the diode. These are the part or the components of the circuit. Next you have to find the current, which is 10 milliampere, 9.3 milliamperes, 6.2 or 6.7 milliamperes. Try it now and tell me whatever you think is the correct answer, guys. I'm still gonna wait for your reply in the comments, and then after some time I'll be continuing the discussion too. Okay guys, let me just tell you a few things here. Whenever you will have a circuit given to you like the closed loop, you will try to use the KVL there, which is Kirchhoff's voltage law. If you will have like just the junctions present in a circuit, you can go for the KCL. KCL and KVL are the two laws which can help you a lot to simplify and to solve such kind of questions. So if I'm going to talk about here, you can apply the KVL like this in the loop. And when you are going to do that, you know it's a negative like 10 volts, but this is negative terminal, so it will give you negative 10. The sum of all the voltages in the circuit, you have to take 0. V is equal to I, and the R is 10 to the power 3K. Like it's 1 kilo ohm, so 10 to the power 3, which means 1000 ohms. So times I plus the diode voltage, I can write it as simply just the VD, or I can write the expression for the diode voltage. Okay, so if I'm going to consider that as just V equal to 0. Now the current I is given in the question, which is this. We can plug in its value at place of I, which will be V minus 0.7 divided by 500. So it will give us negative 10 plus 10 to the power 3 V minus 0.7 divided by, what is the denominator? 500 plus V equal to 0. Just simplify it, get the value of V from here, and that's going to be 3.8 volts. Okay, once you are gonna get this, now you can plug in this value in the current expression to get the final current value. That's it, you got your answer. So this will give you the expression of the or the value of the current after simplifying, same as given in option C, and that's your right answer. Tell me if in case there is anybody having any doubt. We can talk about it, but if it is clear, that's great. Okay, this is how you got the voltage. You have to now plug in the value of the voltage in this current expression. Once you will do that, you will be able to get the current finally. Next question. If anybody wants to ask something or something is not getting clear to anyone, just let me know. I'll be explaining it to you guys. But if it is clear, that's great. Okay, and now the further information given in the question is 01 to 11, 11 to 01, 00 to 11, 00 to 01. Now you can try it. If in case you don't have any idea about like what you need to do or what steps you have to take, I can help you in this case then. But if you think you can do it and you want to try, just do it, okay? And see what steps you think you can take to solve it. If still there will be any doubt anybody will have, I'm gonna start the discussion just in some time, guys. Don't worry. Waiting for your reply, guys. And then in just some time, I'll be continuing the discussion too. Okay, guys. So they are talking about the propagation delay, right? Now, what you have to see, you have to consider the inputs A and B initially like 0, 1, and the second time, initially you just take 0 and 1 here. And you just see like what are the outputs you're gonna get for each gate. So like it will become 0, it will be 0, it will be 0, it will be 0, right? If you are gonna look at the inputs which are going on the particular gate. Then they are saying that the transition has been taken place from 0 1 to 1 1. Now I'll take 1 and 1 here. So 1 1, right? 1 will give you here as 0, so no change. And if you will see here 1 and 0, that will give you 1 here, it's changed. 1 and 1 will give you 1 here, 1 and 1 will give you 1 here, right? So the point is, this has changed, this has changed, this has changed, but this one doesn't change. Now, how many times the delay will be there? So 3 times. Why? Here, when it is changing, here, when the output is changing, when the output is changing. So there are 3 times the delay for each logic gate you will have. Why? Because they have given that the propagation delay of each logic gate is T gate. So every time for each logic gate, whenever the output is changing, there is a delay, okay? And it's 3T gate here for the first option. But how much maximum delay is possible? The delay can take place 4 times too, because there are 4 times we are having the gates present in the circuit. So for that you have to see the other options as well. So when you will check out the other options, check for option D and see is the output changing for all the gates for option D. If you will find like yeah, it's changing, which means you are gonna consider there is delay of 4T gate, right? And that's the maximum delay, and that's what they have asked. So that will be our option D, which will be the correct one. Then you can consider it and tell me if still there is anybody having any doubt. We can consider it, we can talk about it. But if it is getting clear to everyone, guys, then that's great. So let me know if you have any question, query, or doubt. We can talk about it. But this is how, see, the delay is there because when the output is changing, when it's remaining same, there is no delay. But when the output is changing, there will be some time it will take to change the output, and that's considered to be the delay or the propagation delay. Here is the next question, guys. If you have any question or query till now, you can just ask it in the comments. I'll try to answer that part, but if everything is clear, your next question is waiting for you. Consisting of N J K 1 2. This is A, B, S, R. Okay, further. Which of the following connections will allow the entire circuit to act as a JK flip-flop? Connect Q to pin 1. And Q bar to pin 2. Connect Q to pin 2. And Q bar to pin 1. Connect Q to K and Q bar to J. Option D says connect Q to J, input, and Q bar to K input. Consider it now and tell me what do you think will be the correct answer. Whatever you think, okay, it seems to be correct, you can tell me. Still, if you will have any doubt, you can tell me, guys. We'll talk about that part. But if it makes sense and you're gonna get it, we can talk about it. I'm gonna wait for your reply and then I'll be starting the discussion too. If somebody's gonna have any doubt. Okay, guys, let me just quickly tell you what you have to do in this case. Like in the previous question, I have explained you that how the circuit is different for the JK and the RS flip-flop. The same thing you have to consider here. And that's going to be, you're just going to connect the Q bar to 1 and the Q to 2. So that seems to be Q bar to 1 and Q to 2, where it's written Q bar to 1 and Q to 2. It's option B, which is saying the same thing. Hence, option B will be the correct option in this case. You can tell me if in case still you are going to have any doubt, we can talk about it. But for solving any such type of questions, it's very important for everyone to get familiar with the circuits, the outputs, how the particular type of flip-flop works. Okay, so this will be helping you a lot then. You can still tell me if something is not clear. We can talk about it, but if it is, we will go for the next question. Okay, the next one is, this is plus VCC. This is going to be J, K, the clock pulse, try it now and let me know as you will get it done, or if you know this property and the concept. Okay, guys, for this one, it just needs you to know the concept. Basically, the JK flip-flop will be dividing the input frequency into half. So your right answer will be F over 2, which is option D. So it divides the clock frequency by 2, and that's how your F over 2 is the right answer. There is one more question which is quite basic, but let's include it in the discussion so that if anybody doesn't know about it, they will get to know about that too. It's here. Which of the following gates can be used as a parity checker? an OR gate. Option B says a NOR gate. Option C says an exclusive OR gate, which is XOR. Option D says AND gate. So if you know, you can directly answer it. Which one is parity checker? Okay, like the even parity, the odd parity, or if you will see the outputs corresponding to even number of ones or odd number of ones, there is a you can say a fixed thing you can observe, or there is one thing you can say, okay, whenever the even number of inputs are there as a one, or odd number of ones are there, then you are getting this or that output. Okay, or one, only one or two, whatever, like even odd related concept. Whenever the even number of ones are on the input side or odd number of ones on the input side, what kind of outputs you are getting. So that can help you in any such case. Let me know if you know it. Otherwise, I'm going to tell you. So if you know it, you can write it in the comments. What will be considered to be the parity checker? If you don't know, I'm going to tell you. So the XOR, which is option C, gate, is known as the parity checker, which is also known as exclusive OR gate. Okay, XOR or exclusive OR. You can let me know still if you are gonna have any doubt, any question, query, or confusion. We can talk about it. But if everything is clear, then that's great, great, great. So guys, right now we are gonna keep it this much in this session. If anybody is there having any doubt, let me know. I'll talk about it. These are the different type of questions we have discussed today in the session. Even if anybody is having any question regarding any of the questions we have already done in the session today, you can ask that. I'll try to answer it as well. Okay, otherwise let's keep it this much, and thank you so much everyone for joining this session. We'll have more important sessions in upcoming days, and these are more regular right now, like today and then tomorrow again in the morning, and then next day and next day, like that. So you can join and attend all these important sessions, and we will be talking about many important questions, concepts, and the points in our sessions. Also, guys, in upcoming days, many new courses by the top educators will be starting on Unacademy. So if you don't want to miss these important courses and the classes by the top educators, then you can take your subscription, use and apply the code Anjali Live to get the discount in the total subscription amount. And if everything will be getting clear, here in the session, let's keep it this much. But to take your preparation to the next level, you can take your Unacademy subscription as well, whichever you find more beneficial for yourself. Even now the important notes are available on the learning app, which will be helping you a lot, along with the well structured and well planned courses by the top educators to get ready for your upcoming exam. Also guys, generally in these sessions we talk about important questions, concepts, most important points, and many important things we cover up, which are related to your upcoming exams, and they are going to be more and more helpful then. Okay, and will be making you more confident. So you can tell me still if there is something not clear, somewhere there is any doubt, something you want to ask. I'll try to make it clear to you then. Thank you so much everyone for joining this session and for attending it till then. Thank you.